Well, what holds a compound together? Why do the hydrogen and oxygen atoms in water stick together like they do? They are held together by chemical bonds. And there are different kinds of chemical bonds, but they all come down to the same thing. It's attractions between the charged particles, those are the electrons and the protons, that compose atoms. All atoms have protons and electrons. And it's an attraction between charged particles that causes atoms to bond together. We divide chemical bonds into two broad categories, ionic and covalent. Ionic bonds occur between metals and nonmetals. They do not occur between different metals. They do not occur between different nonmetals. It has to be metal-nonmetal. Ionic bonds involve the transfer of electrons from one substance, from one atom, to another. So we've looked at ions and the ions that form from some of the different elements, and we observe that when metals form ions, they always form cations. They do this by losing one or more electrons. So the metal reacts with the nonmetal. It transfers one or more electrons to the nonmetal. So the metal becomes a cation. The nonmetal becomes an anion. Now we have a positive charged ion and a negative charged ion, and they are attracted to each other, and they stick together much like magnets do, electrostatic forces. So in the solid phase of an ionic compound, it's a lot like one of those magnetic building toys, where you have positive, negative, and they just all kind of are attracted to each other. They click together. So we can see this illustrated in the reaction between sodium and chlorine. So here's sodium metal. This is an atomic solid. We've got just atoms of sodium here. Here we have chlorine, little molecules of chlorine. It's a gas, and so they're floating around. What happens is a neutral sodium atom that has 11 electrons will give one of its electrons. It will lose one. The neutral chlorine atom, which had 17 electrons, accepts that electron. So now the sodium ion has 10 electrons. It has 10 electrons, the same number of electrons as neon. Remember, atoms lose or gain electrons so that they have the same number of electrons as the nearest noble gas. Chlorine gains 1 electron, and now it has 18 electrons, the same as argon. We have a positive charge and a negative charge. They attract each other, and they will stick together and form this lattice where we have alternating positive and negative ions. Inside each of these little sodium chloride table salt crystals, have you ever looked at sodium chloride table salt? It's little cubes. Do you think the Morton Salt Company does something special to make them like that because, it would sell more salt? No. That's just what sodium chloride does. It sticks together in this lattice, and that, when it breaks in planes, and it forms these little crystals. Nobody did anything special to make it that way. That's just how it happens. So each of these little salt crystals is an array of these ions alternating, cation, anion. Oops. There we go. So what about a covalent bond? We do a lot with prefixes and suffixes. The prefix co means sharing. Like co-sleeping means you let your kid in the bed at night. Sometimes that's just the easiest thing, right? Covalent has to do with sharing electrons. So covalent bonds occur between two or more nonmetals. Metals are not good at sharing electrons, but nonmetals are. So here we have the sharing of electrons between two atoms. If you have a nonmetal that bonds with another nonmetal, nonmetals, when they form ions, always form negative ions. If they both form negative ions, they're going to repel each other, not attract each other. You can't have ionic bonds between nonmetals because none of them can be convinced to be a positive ion. So what these guys do, instead of transferring that electron, is they share it. So we have a sharing of electrons between two atoms. So here we've got a representation of the nucleus of one, and I'm sorry, I'm having trouble with my pointer, and the nucleus of another atom, and here's the electron that they're sharing. If the shared electron is out here, that's not very stable. It's not the maximum attraction. And if it's over here, that's not the maximum attraction. When the atoms share that electron, they both want to be as close as they can to it. And so this is the most stable situation where we have the electron right between the two atoms. Yeah.
So is ionic the strongest bond then? Or is it covalent the strongest?
That's a good question. So is an ionic bond stronger than a covalent bond? That depends. I'd say if I had to, if you forced me to choose, I'd say maybe the ionic bond is stronger. The strength of covalent bonds depends a lot on how big the atoms are and some other things. And the strength of the ionic bond also depends on sizes and charges. So there is variation, but in general, ionic bonds are very strong. So when we have covalently bound atoms where they're sharing an electron or more electrons, they compose a molecule. So we call these molecular compounds. Molecular compounds have molecules, ionic compounds have ions. These have individual molecules as the smallest particle. Well, we don't have a picture of that. In this ionic compound, there are no discrete molecules where there's just one sodium and one chloride and it's a unit. It's just alternating all throughout. If we back up here, water is a molecular compound. Here, there are individual water molecules. Two hydrogens are sharing electrons with one oxygen atom, and that is a single unit, a molecule.